children's category. So, yeah, just, I don't know. Just propelling me into new, I've sold like 14 books. I don't know. It's a big deal. It's a big deal. Yeah, I probably will have, I'll be retired by the time this whole thing is over. Just saying. What numbers, what's the first one you guys want to see?
119.
Hold on, let me see what I did with fifth period. 119, I did it.
Okay.
Next one after that.
144.
144, I did it.
137.
137, I did it.
I need 20.
23 in the next chapter. Hold on.
147.
147.
143.
I did not do 143 or 147. Yeah, but no one else did. So let's start off with 143. 143. Okay. Oh, yeah. This one. Okay. So, I could not get out of bed this morning. Was anyone else super tired this morning? Was it just the rain?
I actually went.
Huh? It was one of those days. One of those days. All right, 143. I'm in the wrong chapter. I'm on chapter 15. 143 says the following. All right, 143. A 10 milliliter sample of hydrochloric acid solution has a pH of 2. What volume of water must be added to change it to a pH of 4? So here is how I attempted this problem. So I started out like this. I said at pH of 2, my concentration of H plus, right, would be equal to 10 to the negative second to get it out of the concentration, to get it out of the P, right? So that is equal to 1.00 times 10 to the negative second molar. I then found out at pH 4, my concentration of H plus would obviously be equal to 10 to the negative fourth, which is equal to 1.00 times 10 to the negative fourth molar. Are you guys okay with that?
Yeah.
Okay. Then, in order to figure out my moles of H plus present, that would be equal to, on 143, they said I had 10 milliliters. So I said that that was 0.01 liters. You okay with that? And I know at pH of 4, so I know for every 1 liter, I need 0.01 moles in order to make that 1 molar, and that equals 1 times 10 to the negative fourth molar. After that, I said, let V, so V is my unknown, the volume, let V equal the total volume at pH of 4. So I'm going to take my 1.00 times 10 to the negative fourth, which is molar. That's going to equal the 1.00 times 10 to the negative fourth molar over V. What does V equal?
1.
Yeah. So V equals 1.00 liters. That's not my answer though, right? Because I had to figure out my volume added. So it's going to be 1, that's how much I added. So 1.00 liters minus my original 0.01 liters, because I started out with the 10 milliliters. So my volume added was 0.99 liters. So that was 143. 143. Great. Proud of you. Also, there's nothing like that on the test tomorrow. But it's a good one to think about. Good one to think about.
Is tomorrow's test like hard?
It's a mixture of multiple choice on paper and like FRQ type stuff.
Is there going to be vocab stuff like that interview or something?
There will be like you need to know the difference between a Bronsted-Lowry base and a Lewis base. Yes. Arrhenius acid. Yep. Got to know that. Huh? It's like the first page of the notes. First page of the notes. 147, was that the next one? Danny? Does that sound right? Yeah. 147. Consider the equilibrium exercise. Wait, exercise. Oh, sorry. Outlined in 146. So, we are on this one. A condition known as acidosis, which is kind of fun to say. Say that 3 times fast. No, faster. No, a little faster. Okay, thanks. All right, I don't know why I want you to do that, but thanks for playing. Consider the equilibrium outlined in 146. A condition known as acidosis can occur for patients with very weak or slow breathing. The end result is the lowering of the blood pH to dangerous levels. Explain why the blood pH decreases for patients having respiratory acidosis. So let's write out the equilibrium from 146. So in 146, they told me that CO2, right, AQ, plus H2O, liquid, is in equilibrium with H2CO3, AQ, which is in equilibrium, which is kind of weird, with HCO3 minus plus H plus. So yeah, these are all in equilibrium, right? But it's all one big thing. Okay, so don't worry about the double equilibrium. It's kind of weird. If you cannot breathe well, what are you going to have more of in your blood?
CO2.
If I increase my amount of CO2, which way, according to Le Chatelier's principle, is it going to shift?
Right.
To the right. Which means I have more what? H plus. That's it. So that was just Le Chatelier's principle.
Can you explain 145? I'm sorry, is that what you're...
145. Oh, the light bulb. Yeah, I didn't do this one last period either. 145 is a bit tricky for a couple reasons. So, I got a light bulb, right? The light bulb is in a solution. Yes? This solution is acidic or basic? Acidic. So the things they give me are the following. They give me HCl, they give me NaOH, they give me NH4Cl, they give me HCN, they give me NH3, they give me HF, and they give me NaCN. So, at the solute, concentration is about 1 molar. What is the identity of the solute? So, what can I get rid of immediately? The known bases, right? What are my known bases? NaOH, gone. NaCN, gone. What else is a known base here?
NH4Cl.
NH3 is a known base. All the rest of those, we don't know. We're not sure. Okay? I can get rid of at least one more.
NH4.
I can get rid of HCl. Why? That's too strong. Right? It's too strong.
HCN is strong.
Is H...
Not as strong.
That's not one of our memorized strong acids, right?
Right.
So, this light bulb is lighting up. Agreed? Which means that the solution has to conduct electricity. Who said it? Which means it has to be ionic. Which means it has to have a positive ion and a negative ion. NH4 is a +1, Cl is a -1. That's actually an acid. I don't know how you would know that off the top of your head, but NH4Cl is a very weak acid that is also ionic. That's also the only one that's ionic left. Because HCN is covalent, HF is covalent. This is the only ionic compound left that will allow for a transfer of electrons. That was tricky. That was tricky. 145. Anyone get that on their own? Nice.
I did the opposite of you. I found the Ka, so the concentration of H minus and I figured out it was weak acid.
Okay.
So I just found the connect.
Okay, cool. I like that. That was 145. I think that was the rest. Anything else for that chapter? What number? 155 what? 155, I did A. I did B. I already did that. I had 155 A and B. B is tricky because you figure out that it's basically 10% dissociation or ionization, and you have to use that 10% in your ice. That's why that's tricky. But you'll see when I work that second period. That's 155. Next one. 23. I did that one second period. Next one.
2931.
29, 31. I did 29. Let's do 31. Because second period specifically requested 31. Okay. I really don't like these. I actually kind of hate working these. I don't know why I assigned them. But probably because it's good practice. So yeah. I don't know if I'm going to assign these next year. But you know what? You guys got to do them, so you should feel special. What? No. This is harder than the AP exam. You don't have to do these. Where you have to add something to a buffer solution, you don't have to do. What do you mean that's what they want you to think? There's no tricks.
They roll you into a full sense of security.
I have never said that the exam is easy. Who says it's easy? Okay, well, Jacob Hannon. Okay, that's not a good example. Jacob is very, very intelligent. What?
I'd vote for him.
He was president. We should say.
I would vote for any of you over who's running for president. So I'm just letting you guys know that. Either one. I trust you. I let you guys run the country. All right. Why would you want to be president?
Because political influence has no price.
Yeah.
I mean, you'd be rich. Insider trading.
You live on a pension all year. Like,
Really good health care.
You pay for your own gift.
You do? No, you don't. In the White House?
Everybody has to pay.
You have your own bowling alley in the White House. Although now our guys are so old, they probably can't bowl. So, like, I don't see. Oh yeah, the ramp. Yeah, that's how I envision Joe Biden bowling. I'm sorry, but what? Free helicopter rides. Yes.
That's a good one.
Yeah.
Bodyguard.
Bodyguards would be annoying.
Yeah.
I don't know.
Depends on if they're chill.
True.
Do you-
I don't think they're allowed to be chill though.
The turkey.
Yeah. You know that they're like your bodyguards for life then?
yeah.
Yeah. That is weird.
You get like
President is also the job with the highest death rate in the U.S. So,
Highest death rate?
well, because it's a small sample size.
Oh. You mean assassination or people that have died in assassinated or died?
Both, yeah. Because it's a small sample size.
Yeah, what is it? 40 people that have been president?
46, 47.
So what's the death rate? 10%?
Because Grover Cleveland, he did.
Look that up for us. All right, we gotta get this done. I'm gonna get this done. That was on the notes. Yes, I'm glad we got that. 31. I am going to be adding in OH. Agreed? Do I care about the Na? No. And what is the OH going to do with whatever acid? It's going to react.
It's going to take the hydrogen.
It's going to react completely,
Yeah.
right? Yes. So I'm going to have some kind of, this is what I like to do on these. So I have some kind of acid plus OH minus. This is how I write my equations on these. yields water, right?
Yeah.
Plus acid minus, right? Yes, essentially. So on this, the acid that they're giving me on 31, I have to look back to 20. What number am I looking back to? 25. Yeah, 25. So I have so for my R, I have 0.100 molar. For my OH, I also have a starting amount because I have 0.02 moles in 1 liter. So this is 0.02 molar. Water is not involved. Agreed? And I haven't done anything. I haven't made my new acid yet. Why did I put R there? That should have been my I. I was getting confused. I'm like, that's not I. Change. What's my change? Not minus X.
You're minus your 0.02.
Minus the 0.02, because that's my limiting reactant. Right? So minus 0.02, minus 0.02, not part of it, plus 0.02. I have to subtract that. Equilibrium, I have 0.08.
Yeah.
0.08 molar, nothing, not part of it,
Wait,
0.02.
it would be point nine, point nine?
No.
Wait.
0.08.
0.1 minus 0.02. That's 0.08.
Oh, yeah.
Yeah. Yeah, okay.
Got it now.
So now I have concentration of acid and it's what?
Conjugate base.
Salt. So now I can do Henderson-Hasselbalch. You got it. So pH equals pKa plus log of my concentration of salt over my concentration of acid.
Are we gonna have that formula on the test?
Yes.
Yep. Okay.
That's on the equation sheet for the AP, so you obviously will have it on the test. So, pKa. Okay, what is my pKa? Where am I getting that from? Well, that's on 25. That's giving me Ka, right? So negative log of that gave me 4.89. 4.89 plus the log of 0.02 divided by 0.08. So you put that in your calculator.
Negative log, right?
No,
No.
that's not a negative log.
Just log.
In the Henderson-Hasselbalch, just a regular log.
Cool.
So on 31A, I got 4.29. I got 4.29. B is essentially the same thing. Do we still want to do it, or
What do you do for B if they don't give you the KA?
for the Ka? On B, you got to look it up. That's why. You got to look it up.
I don't like this.
You will. They're not going to make you look something up on the AP test. It'll be in the problem.
For H2O, do you use the No.
For which one? For C, H2O is not going to contribute to it. So I would just take the exact negative log of 0.02, right? Because the water's not going to contribute to it. NaOH is a strong base.
Aren't you taking the pH of H2 at that point? Is it
No, because on this one, I would take the POH and then subtract. Take the POH and subtract. So that's 31. Yes?
How'd you know the acid on the product side was the salt?
Because the salt is always, when I rip off the H, this would be like yeah, you got it.
What's the difference between a salt and a base?
It's the same thing. You could have written base over acid, it's the same thing. So you could have written salt over acid, you could have written base over acid, that's the same thing. So that was 31. I realized that there is one that I forgot to assign. So let's quick look at 61. Let's look at 61 really quick
On chapter 14?
on this chapter. I think it'd be helpful to do this before the test. 61 titration curve. We've got a weak acid. So take a second and do that without drawing in your book.
If it even loads, because nothing's been loading this week for me.
Yeah, it took me like a minute.
I just keep like getting security errors.
I'm going to draw it. I caught up on grading today from Disney, so that's nice.
Do we have to do this for like,
Guys, my wife is freaking out right now about Fox 8 thing. She's very excited.
good for her, she should, y'all should. I might actually want to.
Yeah. Do you think I'll have to wear makeup? I hope not.
They might miss you.
You know, for TV, I'll do whatever I have to. If I have to. Gianni.
Cameras wash you out.
So
True.
I don't know if this is, I assume this is not right, so on my Kogyo, I have a 1 out of 10. I think you meant to put like a 10 out of 10?
Probably.
Okay.
Yeah, just kind of all.
Yeah, I spawned it.
I'm going to pass that stuff back in a second.
Yeah, okay, thank you.
Unless you did horrible.
Yeah, I may have just like turned in blank.
I mean, it was mostly just completion, so. Did you do 1 out of 10 worth of work? Okay.
I did the title. Sure you did, but yeah.
Never mind, just loaded.
Are we done?
Calculated how much 110.
All right. A, the equivalence point. Where did you put it?
Like middle of the,
Right there.
where would be?
Right? B, the region with the maximum buffering.
Midway point.
It's going to be anywhere from here, right, to basically there. Yes? But the most is going to be right there. Yes? At the halfway point. C, where does pH equal B, pKa? Also there, at the halfway point. D, where does pH only depend on HA? Before I've started it, right? Because this is before nothing has dissociated. It's already weak acid, so it's not doesn't want to dissociate very well anyways. What about where's the pH only to depend on the salt?
At the very end.
At the equivalence point. Nice work. It would be at the equivalence point, because at the equivalence point, all of the H and OH have turned into what? Water. So I only have the salt there, which you can see up there. And then pH depends on the amount of excess strong base added. Anything after this. So from here on is going to be F. There on is going to be F. All right, I have a surprise for you guys.